Hello everyone, welcome to this SQLAlchemy crash course. In this course, we will cover setting up SQLAlchemy, creating models, relationships, creating, updating, and deleting records using SQLAlchemy. We will also learn to query the database, join tables, load related models in order to avoid extra queries to the database, as well as database transactions. We've got a lot to cover, so let's begin. If you want to follow along with me, feel free to do so. I use PyCharm Professional Edition, but you can use any IDE of your choice. If you want to use PyCharm, head to jetbrains.com/PyCharm/download. There are versions for Windows, macOS, and Linux. There are two versions, Professional and Community Edition. With Professional, you get a few more tools, such as the database viewer I'll be using in this video. You also get a 30-day free trial if you want to use this tool before you start paying for it. So here we are in our IDE and we're going to initialize our project. So I'm going to head to my terminal and I use Poetry for my virtual environments. You can use any tool you like. However, I like to use that. So I'm going to do Poetry init. And here I'm going to initialize it. And I am going to install SQLAlchemy. So this is the first one, so it's 0. Any version will do. I don't want any development dependencies, and that's it. So yeah, you can install SQLAlchemy globally on your machine if you like. So you can do pip install SQLAlchemy. However, like I said, I'm using Poetry. So I'm going to say Poetry install. Okay. So now that we have SQLAlchemy installed, we're going to head to our project and we're going to create a file called main. So in this file, we're going to create our base directory. So we're going to say base directory is equal, and here we're going to use the Python OS module. We're going to say os.path.dirname, and here we're going to say os.path.absolutepath, and here we're going to pass the name of our file. And here we're going to create a database engine. So we're going to say create engine, and this is a function from SQLAlchemy, so we're going to import that. And we're going to pass an f string, and we're going to say SQLite : 3/, and here we're going to say base directory /db. So this is what we're going to call our database. And here I'm going to set the echo flag to true. And this is so we can see the SQL commands in our terminal. So here I'm going to say session. And I'm going to say scoped session. So we're going to import that again from SQLAlchemy ORM. And here we need another function called session maker. So we're going to import that again from SQLAlchemy ORM. And here we're going to say auto flash to false, auto commit to false, and we've got to bind our database engine. So we're going to say engine. And here we're going to add an event listener, and this is for SQLite. So this is essentially, we're listening for an engine connection, and if this is an SQLite connection, we want to set the foreign key constraints to on, and this will help with our cascading deletes. Now we will start creating our model. So we're going to head to our project, and to organize things, we're going to create a Python package, and we're going to call it models. So within that, we're going to create another Python file, and we're going to call this base. And in the base, we're going to have the main model and some other base models. So I'm going to say model, and I'm going to say declarative base We're going to import this from SQLAlchemy ORM. Okay. And here we're going to set the model.query because we want to query all our models from within our model. And we're going to say session. So we're going to import the session we created in our main file. And we're going to say query property. And here we're going to create a base model. So we're going to say timestamp model. And this is going to inherit the model we just created. So I'm going to explain exactly what I'm doing here. So this is essentially a model that will create timestamps for all of our models in order to not create them for all our models. So here I'm going to set this as abstract. When you want to have a model that is abstract and does not need to be concrete, you set this to true. And here we're going to say created at, and here we're going to start the definition of our model. So we're going to say column, and we're going to import this from SQLAlchemy. So here we're going to say what field this is, and this is a datetime. So we're going to import datetime again from SQLAlchemy, and we're going to set the default to datetime.utc now. So we're going to import this from the datetime module. So we're importing datetime from datetime. Okay, so what happens is whenever this model gets created, the default UTC now time will be added to the created add column. And here we need an updated add, and we're going to say this is a column again, and we want a datetime. We're going to leave the default to none. However, we're going to say on update, we're going to say datetime.utc now. So whenever the model gets updated, the updated add timestamp will get created as well. So here we're going to start with the creation of our user related models. So I'm going to create a Python file called user, and we're going to keep all of our user related models inside this file. So I'm going to say class, and we're going to create our user model, and we're going to inherit from our timestamped model. So I'm going to import that. And here we have a special class attribute called _table name, And this overrides the default table name for this model. So the default is the user model. So in this case, it would be user. However, I want it pluralized, so I'm going to say users. And here we can start with the definition of our columns. So I'm going to say I want an ID, and I want this to be a column. So we're going to import this. And here I want this to be an integer. So we're going to import that again from SQLAlchemy. And here I'm going to say that this is the primary key. So we're going to set this to true. And here we're going to say auto increment to true because we don't want to set this ourselves. It will auto increment every time a new record gets created. So here I want a first name. So we're going to say column, and here we want a string. So we're going to import this from SQLAlchemy again. And here we're going to set the length of that string. So I'm going to say 80 characters. And here I'm going to set this nullable to false because by default it's true, but I want this to be a required field. So I'm going to duplicate this, and I'm going to say last name, and I'm going to keep it the same. Here I want an email, so we're going to say column, and here we want a string again. I'm going to make this a bit bigger. I'm going to make this 320 characters. We're going to say nullable to false, and here we're going to say unique to true. So what the unique does is a unique constraint. So essentially we cannot create two records in this database table with the same email. And this is because we want the email to be unique. And here we're going to override our representation method just to get a clearer understanding of what this model is. So we're going to return, I'm going to pass an f string, and here we're going to say self.class, and here we're going to say the class name, and here I'm just going to say name, and I'm going to pass the full name of the user. So I'm going to say self.firstname, and here I'm going to say self.lastname. Okay? And our user is created. So now that we have our user model, we want the user to have some preferences. So we'll create a table called preferences, and this will be a one-to-one relationship between the user and the preference. So here we're going to say class preference, and we're going to inherit again from our timestamp model. And here we're going to change our table name, and we're going to set it to the plural, so preferences. So here I want an ID, and this is a column, and this will be an integer. It will be a primary key. We'll have auto increment to true. And here we're going to say language. This will be one of our preferences. So this is a column, a string. We're going to set it to 80 characters. We're going to say nullable to false. We're going to duplicate this, and we're going to say currency. And this, we can leave it to 3. And here we need to create the foreign key. So we're going to say user ID, and we're going to say column. We want this to be an integer. And here we create the foreign key. So we're going to say foreign key, and we're going to import this from SQLAlchemy. And here we're going to set where this is pointing to. So this is pointing to users.id. So this is the table name and the column. So it's pointing to the ID column of the users table. And here we're going to set this nullable to false. And here we're going to create an index for finding the records faster. And we're going to say this is unique to true because we only want each user to have one preference. And here is where we define the relationship. So we're going to say relationship. So we're going to import this again from SQLAlchemy ORM. So here. And here we're going to put the model name that we're referencing to. So this is user. And here we have a special keyword called backpopulates, and this is what the field will be called on the user model when trying to get the preference of that user. So here we're going to call this preference, and this has to match what we're going to add here. So we're going to say preference. So this one here needs to match this one here. So we're going to say preference is equal to a relationship, and here we're going to do the opposite for the user. So we're going to say preference. Okay, and here we're going to say backpopulates, and here we're going to say user. Here we're going to say useList, and we're going to set this to false, and I explain exactly why we're doing this. And this is because we've got a foreign key here on the preference, So if we had not set this to unique, you could have had one or more records. So this just tells the ORM that we're expecting a single item and not a list. Okay? And here we're going to set this to passive deletes as true. And I'll explain what this means. Also, here we need to say on delete, and we're going to set this to cascade with capital letters. So what this means is, so what should we do when the user gets deleted? So we're saying delete the preference as well. But when using SQLAlchemy, the default behavior is to set the foreign key to null. And passive deletes essentially means leave this to the database. So essentially, because we've got a foreign key constraint and we're saying on delete cascade, the database will handle the deletion of the related model. So in this application, our user will have multiple addresses. So we achieve that with a one-to-many relationship. So here, we're going to create an address model, and we're going to extend timestamp model. We're going to set our table name. We're going to set it to addresses. Okay? And here we're going to create our column. So we're going to say ID is a column, which is an integer, and is our primary key. And auto increment should be true. Okay? So here we're going to have a road name. We're going to set this to a string. We're going to leave this to 80 characters, and we're going to set this as nullable to false. Okay, so here we need a couple of more columns. So I'm going to duplicate this, and here I'm going to say postcode, which is going to be, again, a string column that is nullable of false. And here we're going to have a city, which is exactly the same thing. And here we're going to create our foreign key definition. So we're going to say user ID is equal to a column. We want this to be an integer. And here we're going to say foreign key. We're going to say this points to users dot ID. So the same as before. And here we're also going to say on delete cascade, because we want to delete this record if the user gets deleted. And here we're going to say nullable to false, because this is a required field, and index to true. Okay, and here we're going to create the relationship. So we're going to say user is equal to a relationship, and here we're going to specify the user model. Okay, and here we're going to say backpopulates, and here we're going to say addresses. And the reason we're saying addresses is because a user can have many addresses, but an address can belong only to one user. That's why we're saying one to many. So here we're going to define the reverse relationship. So we're going to say addresses is equal to a relationship. And here we're going to say address because that's our model name. And here we're going to say backpopulates. And here we want user because, like we said, the address can belong only to one user. So here we used useList of false previously, and this is because this was a one-to-one relationship. And because this is a one-to-many, we're not going to specify this because the default is true. And here we're going to say passive deletes true because we want the database to handle the deletion of the records. So we're going to go here and we're just going to override the wrapper function, and we're going to return an F string, and we're going to say self dot double underscore class double underscore, and here we're just going to say name because we want the class name, and here I'm just going to say name, and let's just add the city. So I'm going to say self.city. You could add anything here. It's just what gets printed to the screen when you print that model. And here we want our user to have many rows, but also the rows can belong to more than one user. So this is what we call a many-to-many relationship. So here we're going to create a model called row, and this will extend model. So here we're going to define our table name, and this will be rows. Okay, so here we're going to define the ID, which is an integer column, and the primary key will be our ID, and auto increment will be set to true. So here we want a name. This will be a string. 80 characters will be enough, and we're going to set nullable to false. So I'm going to duplicate this, and here I'm going to have a slug, but in addition to nullable, I'm going to have unique set to true. And that's because we only want one row for each slug. So we cannot have two rows with the same slug. And in our case, the rows will be admin and super admin. So here, I'm going to override our function for the representation of our class. And here I'm going to return an f string. And here, let's just print the class name. Okay. And I'm also going to print the name of the row. So we're going to say self.name. Okay. And here we need one more model. And this is because a user can have one or more rows, and a row can belong to one or more users. So this cannot be achieved with a foreign key. So what we need is another model that represents a pivot table. So a pivot table is a table that holds information from two database tables. In this case, the row and the user. So we're going to create this pivot table. We're going to say user, row, and this is a timestamp model. And here we're going to say table name. We're going to set this table name as user rows. So here I'm going to have the user ID. So this is a column of integer, and here we need a foreign key to our users table ID. And here we're going to set on delete to cascade. And this is because when we delete the user, we want the user role to go as well. And this will also be our primary key. So I'm going to duplicate this, and here we're going to say row ID. And this will refer to the rows ID. So I have both of them as primary key, and this is what we call a composite primary key. So essentially, two columns comprise the primary key of a table. And this is the convention when using pivot tables. So you don't need an ID as a primary key. So we're going to go to our row model here, and we're going to define the relationship to the user. So we're going to say relationship user, and because we're using a pivot table, we need this keyword argument here called secondary, and we need the name of our secondary table. So this is user rows, and here we're going to say back populates, and this will go back to our rows. passive deletes will be true because we want the database to handle the cascades. And we're going to go here as well to our user and define the rows relationship. So I'm going to say rows relationship, and this refers to row. And here we need a secondary as well, and this will be again user rows. Here we need back populates, and this will be users. And here we need passive deletes, and we need to set that to true. So this is how you define the many-to-many relationship. So essentially we've got one of our models, our second model, and our pivot table, which has the foreign keys to both of the other tables. So now that we have defined our database models, we are going to create our database together with our tables and also seed the database with some data. So I'm going to head to my terminal. I'm going to open a Python 3 REPL, and here I'm going to say from main import the engine. So from our main file, we're going to import the database engine, and we're going to say from models.base, we're going to import the base model. And also we're going to import our user model. So I'm going to say from models.user import everything. And here we're going to say model.metadata.create all. And here we're going to pass our database engine. So as we can see here, our database has been created. So I'm going to exit the Python REPL. And here we're going to seed the database. So I've got a file here that seeds the database. So we're going to say Python 3, and here we're going to say seed.py. So we've seeded the database. So we're going to head to our database viewer, and I'm going to load our database. So it's an SQLite database. You can use any database viewer, but I'm using the one that comes with PyCharm. So here I'm just going to select this file here, which is DB. So we're going to test the connection. We can connect, apply, OK. So if we try and view the database, I'm going to refresh. We've got 6 tables, which are addresses, preferences, rows, user rows, SQLite master, and users. So if we load this, here we have our sample users. So now that we have seeded our database with some data, we are ready to start querying it. So here I'm going to fetch all the users. So I'm going to say all users, and here we're going to use this session that we created. So we're going to import that from the main file, and here we have a query function, and here we're going to add our user. So I'm going to import our user, and here we're going to call all. So if we print all users and we run this, we get all of our users. However, if you remember from base, we added to the query property of our base model the query property of our session. So essentially, because we did that, we don't need to do this here. We don't need to use the session. So we're going to say user.query. We don't need this part here. I'm going to remove this. So essentially user.query.all. So if we run this, we get all of our users exactly the same. So grabbing the first user is quite trivial as well. So we're going to say first user, and we're going to say user.query.first, and we're going to print this user. So if we run this, we get our first user. So if you want to filter by a specific attribute or a specific column of a model, we do this way. So I'm going to say Johns. So I want to get all the Johns. So we're going to say user.query, and here you can do filter by, and here we add a keyword argument, which is the column name. In my case, it will be first name, and here we're going to set this to John. And here we're going to call all again because we want to get all the users that match this criteria. So we're going to print John's. We're going to run this, and here we have a list with one user called John Doe. However, here you can use the filter method as well. So I'm going to duplicate this, I'm going to comment this out, and here instead of filter by, we're going to say filter, and here we're going to say user. So we're going to essentially access the user model, and we're going to say .first name, and here we're going to say equals a comparison. So user.first name is equal to John. So if we run this, we get the same result. Okay, so we have a couple of more ways of filtering. So here I want to get all of my Gmail users. So essentially all of the people that use a Gmail account. So I'm going to say Gmail users, and the way I'm going to achieve that is I'm going to say user.query.filter, and here we're going to say user.email, and here we have a method called like. And like accepts what we're trying to search by, and here we're going to put a percentage. So the percentage means one or more characters. So we're saying there's going to be one or more characters, we don't know what that will be, and then there will be at gmail.com. So essentially this string will be at the end of the email column, but we don't know what is previously. So here we're going to say all, and here we're just going to print the Gmail users. So if we run this, we get 1, 2, 3 users that have a Gmail account. So if we want to confirm here, we're going to go users here. Let's see. So John Doe, that's correct. Then it's Jane Smith and Bob Johnson. And then the rest are example.com. So they didn't match, so we didn't get them back. And another method you might want to know is iLike. So iLike is the same as like, but essentially it's case insensitive. So it will basically lowercase the two strings that are being compared. So it will be case insensitive. Okay. So moving forward, I want to get all of my users that are super administrators. So I'm going to say super admins, and we want to fetch them. So I'm going to say user, and here I'm going to say .query. And because we want to continue this, I'm going to put this in parentheses. So I'm going to put that like so. So we're going to say user.query. And here we want to filter by the row. So we're going to say row.slug is equal to super admin. Okay. And then we want to call all. Okay. So if we import this, however, here we have a problem because we want to filter by the row and the slug of the row. However, we haven't joined this table. So if I run this, I'm going to print this anyway. I'm going to say super admins, we're going to get an error. So here we're getting an error saying that the statement has a Cartesian between a from element rows and from element users, and is suggesting that we apply a join condition. And this is what we're going to do. So we're going to say here .join, and because we're joining from the user table, we're going to say user dot, and here we want the rows. So if we run this, we no more get the error. So we get all of our users that are super admins. Okay. If we want to order the results of a query, we do this in this fashion. So we're going to say users by name, and here I'm going to put user.query, and we achieve this by the order by function. So we're going to say order by, and here you can put the column name. So you can say first name, or you can say user.first name. It's the same. So we're going to say all, and we're going to print the users by name. If we run this, we get Alice, Bob, David, Emily, Jane. But we can achieve the same, but in descending order. So I'm going to copy this. I'm going to put it here. So you can say users by name. And here we're going to say in descending. And here what you need to do is call a function called descending. So we're going to import that. And this is basically from SQLAlchemy import descending. So this is a function. So we're going to wrap our column definition here. And here we're going to say users by name descending. So if we run this, we get all of the users in descending order of their first name. So we got Michael, John, Jane, Emily, David, Bob, and Alice. So we can sort by two columns. So essentially here we were sorting by the name in descending order, the name in ascending order. However, if two columns are the same, you can sort by a secondary column as well. So essentially what I mean is, let me duplicate this here. So I'm going to duplicate this and I'm going to say first name and then I'm going to say last name. So users by name descending by names. I'm going to say by names because we do both first and last name. So if we print the users by names, you see here we've got Michael Davis, John Doe, Jane Smith, Evelyn Nguyen, David Kim, Bob Johnson, and Alice Lee. So this might seem the same as before, but essentially if one of the names, for example, if one of the names was the same, then it would have done a secondary sort by the last name. And you can see this in the SQL statement. So from users, order by users.first name descending and users last name descending. Okay. So we can limit the results of a query. So I'm going to go here and I'm going to say first 3 users. And here we're going to say user.query. And here we're going to say all. And I've seen this in a wrong way previously. So I've seen it like this. So I've seen it like this. So 3, this is wrong. This is wrong because the SQL statement that is sent to the database is wrong. So I'm going to prove this to you. So we're going to say first 3 users. We run this. There you go. We're selecting all of our user columns from users. There is no limit. And essentially the limit is happening by Python. So essentially we're creating a new list by copying this existing list. So this is not the correct way to do it. It is not efficient. So the way you do it is by calling the limit function and you say how many you want to limit by. So if we do this and we run this again, we get the same 3 users. However, if you have a look here, we limit by question mark and see if here if we see the bindings, we limit by 3 and we offset by 0. Okay, before here. So here we want to skip 3 users. So I'm going to say skip 3 users. And we're going to say user.query.offset. And here we can specify how many we want to offset by. So I'm going to say offset again by 3. We're going to grab all of them. And here we're going to say skip 3 users. And we're going to run this. So here we get 3 different users. And here if we see the offset is 3. And finally here in terms of querying, we can count the number of records. So I can say number of users and we can say user.query.count. And if we print this, we run it, we get 7. So now we're going to start adding data to our database using SQLAlchemy. So we're going to achieve this by creating instances of the models. So I'm going to create a user model. So I'm going to say user. I'm going to import that from our models. And here I'm going to add the columns. So I'm going to say first name, and this will be added as keyword arguments. And here we're going to say John. We're going to say last name, and we're going to say Smith. And here we need the email as well. So we're going to say johnsmith@gmail.com. So we need to add this user to the session. So we're going to import our session. And we're going to say add. And then we're going to pass our user. So there's another way of setting the columns on the user object, and I'll show you that one as well. So we're going to say user2 is equal to a user object. So we're going to instantiate that. So here I'm going to say user2 dot first name is equal to Jane. And the advantage of this is that we get IntelliSense. So I'm going to duplicate this a couple of times. So here we're going to say last name, and this one will be the email. So we're going to say Doe, and the email would be janedoe@gmail.com. And we can add this user to the session as well. So we're going to say session.add user2. So I'm going to create a final user, and this is just so you can see that we can associate related models and add them all to the database in a single go. So here I'm going to say user3, and we're going to create another user instance. So we're going to say first name, we're going to say J, I'm going to duplicate this a couple of times. So we're going to say last name, and this one will be the email. So the last name is Jones. So here we're going to have jjones@gmail.com. Okay? And here we're not going to add the user to the session just yet. We're going to associate the related models. So we're going to say user3.rows.append, and we use append because rows is a list. So here we need to add a row. We're not going to create the row because the rows already exist. We just associate them. So here I'm going to go and fetch the admin row. So we're going to say row. We're going to import that, and we're going to query the database. So we're going to say filter. And here we're going to say row.slug is equal to admin. And here we want to get the first record. So we're going to say admin row, and now it's appended. So we're going to add one address for this user. So we're going to say user3.addresses.append, and here we need to create an instance of the address model. So we're going to say address, we're going to import that, and here we need to set the fields. So we're going to say road name is equal to 34 main road, and here we're going to duplicate this a couple of times. We need the postcode, and we need the city. So we're going to set the postcode as IG11 4XE. We're going to set the city to London. And finally, we're going to add the preference to this user. So we're going to say user3.preference, and this is a one-to-one relationship. So we assign a preference model here. So we're going to say preference, we're going to create one, and we're going to set the required field. So we're going to say language. We're going to set this to English. And here we're going to say currency. And this will be GBP. And finally, we add the user to the session. So we're going to say session.add user3, and here we commit the whole transaction. So this will add all the records to the database. So if we run this, all the records get added. So if we go to our database and we look at our users, here we've got John Smith, Jane Doe, Jay Jones, and here if we go to the user roles, so Jay was the only one that we gave him an admin role, so user of ID 10. So we've got the user roles, user ID of 10 has the role ID of 1. And if we go rows, role ID of 1 is admin. Okay, and also the address got added as well. So here we've got the address and user ID of 10. So now we're going to start updating some records in our database. So I'm going to start by fetching the user preference of John Doe. So I'm going to say user preference, and this will be our preference model. So I'm going to import that, and we're going to query. And here we're going to join to the users table. So we're going to say preference.user, and this is because we want to filter by the user email. So we're going to say user, and we're going to import that user. So we're going to say equal John Doe @gmail.com. And here we're just going to say we want the first record. And here we're going to print the user preference, and we're going to get the currency. So if we run this, we get USD. So here we're going to try and update this currency. So we're going to go here and we're going to say user preference.currency, and we're going to set these to something else. So I'm going to say GBP. And here I'm going to commit the session. So I'm going to say session, import the session, and commit. So now if we rerun this, we get GBP. So if we even go to our database here and we go to our preferences, here we've got this preference which belongs to John Doe, and we've got GBP. And also, if you note here, we've got an updated add timestamp. And this was because we configured our timestamp model to update and set a timestamp whenever the model creates a new update on the record. So moving on, here we're gonna update another model with a different way. So here I'm just gonna say user, and we're gonna query this. So we're gonna say filter. So we're gonna say user dot first name is equal to John. So we're gonna duplicate this, and we're gonna do the same for the last name because we want to find a specific user. And here we're gonna say first. Okay, so we're gonna fetch this user, and we're gonna check something before we do something with this. So we're gonna print the user, and here we're gonna get their email. So if we run this, we get johndoe@gmail.com. However, what if we want to update that email? So instead of fetching the user, we're going to say update, and here we're going to pass a dictionary. We're going to say email, and we're going to set the new email. So we're going to say johndoe@hotmail.com, and here we need to commit the session. So we're going to say session.commit, and here if we run this, and if we go to our database with our users, here we've got John Doe @hotmail.com, and here we've got the updated timestamp as well. So these are the ways you can update a model. So here I'm going to show you how you can delete a record from your database using SQLAlchemy. So first we're going to fetch a user from the database. So we're going to say user, we're going to import this model, and we're going to fetch the first user. Doesn't matter which one. So here we're just going to print this user to see which user this is. So if we run this, it's John Doe. So here, the way you delete the user is by grabbing this session and calling delete, passing the user, and then committing the session. So now I'm going to refetch a user from the database, the first one again, to see if that user exists. And we're going to print the user. So if we run this, we get Jane Smith because John Doe got deleted. So if we confirm from our database here, there is no John Doe. Even the ID has gone. So what is eager loading? So eager loading is when you load related records together with the main record. So if I start here and I fetch my users and I say user and I import my user model and I query that model, and let's say I want to fetch all my users. Okay, so here we fetched all of our users, so let's loop through our users. So I'm going to say for user in users, and here we're going to print let's say the user first name. So if we do this, this is fine. We print all of the names and we've only run one query. However, what if I say I want the, let's say, the addresses of the users? So if I run this, here is where the problem arises. So we first select our users data from our users table. So that is one query. And then whenever we try to access this property here, addresses, an extra query is sent to the database to get those addresses. So this is quite wasteful. We want to do that in a single go in one query. And this is where eager loading comes into play. So the way we achieve that is here we say options, and here we've got several versions of eager loading. So I'm going to start with the joint load. So I'm going to import this from SQLAlchemy ORM, and here we're going to say user dot addresses. So if I run this, if you see, we get all the addresses, and here we've got a single query. So we select the fields from the user table and we left outer join the addresses. So within one single query and a join, we can get all of this data. However, we also have the subquery load join, and this is a bit different. So if we run this, we get the same result but with two queries. So first we get the user data from the users table, and we run a subsequent query, which is a subquery, to get the addresses from a subquery here. So you might ask, which one should you use? It depends on the structure of your data. You should try both. I find it that when you have a complicated matrix between your data and you've got very deep nested joins, you might want to use subquery load instead. But try it out and see what works better for you. And finally, we have another join called contains eager. So this comes into play. So if we say here contains eager, so this is essentially expects you to have joined the tables prior. So here we have to say join, and we have to perform the join ourselves. So here we're going to say user dot addresses. So if we run this, we get the same result that we got from the first example. So it's a single query where we're selecting our addresses and our users by performing a single join. However, you would use this when you would want to scope something down. So for example, I want to say I want to get all the users that have at least one address in London. So I would do here filter, and here I would say address. So I'm going to import that, and then I'm going to say city is equal to London. So if we run this, we get all the users that have at least one address in London. But if you see here, you only get the addresses of those users in London. You might want all of the addresses of those users. In that case, you would still join to filter, and you would use one of the other joins. So here I can say join load. I will still get 2 users, but I will get more addresses. So if we run this, we get 2 users. One has only one address, and the other one has one address in London and one address in Birmingham. So this is the way you should use eager loading with SQLAlchemy to avoid extra queries to the database and the so known problem n+1. So what are database transactions? So by definition, database transactions are a sequence of operations performed on the database and served as a single unit of work, meaning that it all happens or none of it happens. So let me explain with an example. So let's say here we have an API that wants to create a user together with their preference. So let's start by creating our user. So we're going to say user, and I'm going to import my model. And here I'm going to say first name is equal to John. And here I'm going to duplicate this a couple of times. We're going to do the last name. We're going to say Smith. And here we're going to say email. I'm going to say jsmith@gmail.com. Okay, so all good until now. And let's say we want to add the user to our session. Okay, and this is where it starts to all break down. So here, let's say I was to commit the transaction, okay? The problem would be, what if something happens after this line and we add the user to the database? Well, the problem with that is we would have a user being created without their preference. So here, for example, I'm going to say preference, and I'm going to import our preference model. Okay. And let's just say that the language is English. Okay. And here the currency is GBP. Okay. And here we also add the preference to our session. Okay. But here we would do preference.user is equal to user. All right. And then we would do session.commit. Okay. So this would work. Okay. However, what if, like I said, something happens here? So let's just raise an exception here. Okay. We're just going to say something went wrong. Okay. So this could be anything within our application. So if we run this, okay, we get the exception. But if we go to our database, we see that our user has been created. But if we go to the preferences, we don't have a preference for that user, which is a problem. So let's just delete this user, and I'll show you how database transactions can save us from this situation. So what you would need to do is you would need to remove the commit statement here, meaning that nothing has been committed to the database, okay? And you commit at the end. So if we rerun this, okay, we get the exception. And if we go to the users, and if we refresh, we don't get the user added to the database. And it's exactly what we were saying in the beginning. Everything gets added or nothing gets added. We want to have a consistency. So that's why we use transactions and we commit the transaction at the end of all our ads. I hope you have enjoyed this video, and if you have, please like, comment and share the video, as this helps the channel grow so I can keep making these videos. I upload new videos every week about Python and related frameworks, so if you want to get notified when I do, please subscribe as well as click the notification bell so you can be notified whenever a new video is released. Thank you for watching, and I'll see you in the next one.